All right, so example 1, we're going to write the equation of the function shown. And so to start, I'm going to identify that this is an absolute value function. And so the transformed form of this would be y equals a x minus h plus k. All right, and so I know my h and my k are going to come from the vertex here. So my vertex is negative 4 comma negative 2. And so right away I know my equation will be y equals a times the absolute value of x plus 4. Remember, it's minus a negative 4, then minus 2. And so now we just need to find a point on our graph to plug in for our x and our y. So I'm going to use the point negative 1, 0. And I'm going to plug in my x and my y values. So 0 is going to equal a times the absolute value of negative 1 plus 4 minus 2. So 0 is going to equal negative 1 plus 4 is 3. And so this becomes 3a minus 2. I'm going to add 2 to both sides. And so a will equal 2 over 3. And so my equation of the graph shown here is y equals 2/3 absolute value of x plus 4 minus 2. Identify the h and the k. Plug in a point to find the a value. Example 2. Write the equation of the function shown. This is a quadratic, so I know my parent function is y equals x squared. And so my transformed version will be y equals a, x minus h quantity squared plus k. And so my h and my k are going to be the vertex again. So right here is my h and my k. And so my vertex is 1, 1. And so right away I know my equation will be y equals a times x minus 1 quantity squared plus 1. I'm going to find another point on the graph. Well, they give me the point 4, 5. So I'm going to use that to find a. So I plug in 5 for y equals a. I'm going to do some mental math. 4 minus 1 is 3 squared plus 1. 5 equals 9a plus 1. 4 equals 9a, so a is 4/9. Our equation, y equals 4/9 x minus 1 quantity squared plus 1. Find your h and your k. Find a point on the graph to find a. Write the equation of the function shown. This is a cubic function. So our next example is this graph here. This is an example of a cubic function. Right? The general form of a cubic function, it's increasing, it's going to level off, and then it's going to start increasing again, and then you have this point of inflection right there. And so the transformed form would be a times x minus h cubed plus k. And so h and k are going to come from the point of inflection, where the other two are the vertex. So the point of inflection here is 2, 1. And so I know the general form is going to be y equals a times x minus 2 cubed plus 1. Now I'm going to find a point on my graph, and it looks like I have the point 4, 5. To find the a value. So I'm going to plug in 4, 5. So 5 is equal to a. Some mental math. 4 minus 2 is 2. Plus 1. 5 equals 8a. 2 cubed is 8. Plus 1. 4 equals 8a, a equals 1/2. And so the equation of this graph is y equals 1/2 x minus 2 cubed plus 1. Again, we need to be able to identify the h, the k, and then one of the key points, which is one of the key points in most of these graphs. Once you find that, use another point on the graph to find the a value. In this case, we used 4, 5, but we just as likely could have used 0, -3. Our next example is a reciprocal function. That's our parent function, and so the transformed form would be a times 1 over x minus h plus k. And so in this case, the trick to finding h and k are actually in your asymptotes. And so our horizontal asymptote is y equals 2, and our vertical asymptote is the line x equals 4. And so this is actually our h value, and this is actually our k value, right? It comes right from the asymptotes. So our hk, in this case, I'm writing them as an ordered pair, is 4, 2. Therefore, y equals a times 1 over x minus 4 plus 2. Now I'm going to find another point on my graph, and it looks like I can use the point 5, 5. So I'm going to use the point 5, 5 to find a. So 5 is equal to a times 1 over 5 minus 4 is 1 plus 2. So 3 is equal to a. And so we have our equation. Y equals 3 times 1 over x minus 4 plus 2. So in this example, finding your h and your k come from the asymptotes. Here, we have an example of a cube root function. And so we're going to look for, so this is very similar to our cubic function. We're going to find the point of inflection. And so that's where it changes concavity. And so here it occurs at 3, 3. And so I know I have y equals a times x minus 3 to the 1/3 plus k, plus 3, because we know our h and our k. Now I'm going to find another point on the graph. It looks like I have the point 2, 2. So I'm going to plug that in. 2 equals a, 2 minus 3 to the 1/3 plus 3. Well, 2 minus 3 is -1, and -1 to the 1/3 is -1. So this becomes -a plus 3. -1 equals -a, and so a equals 1. And so the equation here is y equals the cube root x minus 3 plus 3. Again, in each of these, we're finding the h and the k values. Then we're going to plug in a point from our graph to find the a value. So in this example, we're going to write the equation of a log base 2 transformation function. This is probably the hardest one to do. It's pretty involved. But if we start and look, we know what our h value right away is from the graph by looking at our vertical asymptote. And so that occurs at x equals -3. And so this is actually our h value. And so we can write the equation a times log base 2 of x plus 3 plus k. So plus 3 because we do minus a -3. Now to find the k value, what we need to do is find what value of x makes our log 0? Well, to figure this out, right, we know that 2 to the 0 equals 1. And so I know that has to be what is my argument, so x plus 3. And so at x equals -2, I get my 0 value. And so if I look at the graph, I'm going to go to -2, and I'm going to find my k value, which is the y value right there. So at -2, 4, we're 1 away from the vertical asymptote. That's actually going to give us our k value. And so now we know y equals a times log base 2 of x plus 3 plus 4. So to think of the k value, it's going to be the y value of the graph 1 unit away from the vertical asymptote. Now to find the a value, we find another point on our graph, and it looks like I have the point 1, 6. And so 6 is going to equal a times log base 2, 1 plus 3 is 4, plus 4. So subtracting 4, 2 equals a, and log base 2 of 4 is 2, and so a equals 1 in this case. And so our equation for this one is y equals log base 2 of x plus 3 plus 4. So again, a little trickier for our logarithm one. Find the h from the vertical asymptote. The k value is 1 unit away from the vertical asymptote. So you're going to look at the graph 1 unit away on the x-axis. The y value there will be our k value. And then use another point to find the a value. Final example is a exponential function, and I'm telling you that the base is 1/2 x. And so the k value comes from the horizontal asymptote. And so right away I know y equals a times 1/2 to the x minus 4. All right, so again, this is your horizontal asymptote. To find a, we're going to plug in another point. So I'm going to use the point 0, -1. So -1 is equal to a times 1/2 to the 0. We already know the k value is minus 4. Well, 1/2 to the 0 is 1. Adding 4 to both sides, we get 3. And so I know my a value now. So y equals 3 times 1/2 to the x minus 4.